Hey guys, welcome to part 3. This one's going to look at the regression side of things. So the key with the regression analysis is basically we're trying to get to the point where we can make certain predictions. So in our case, we would be interested in, say for example, I did the normal 3MT test. I'm interested in, would I be able to predict what your VO2 max value is based on some of the measured variables, right? So we obviously took a whole bunch of aspects that we try to measure or calculate in terms of what their critical velocity was, or what the d prime was, or what their maximum distance was. Maybe something like age or height or weight affects what your VO2 max ultimately is. So to get to that point where we can eventually do the test without having to actually measure what your VO2 max is, developing a regression equation would facilitate that process. Obviously, accuracy to general population would be limited because of the fact that our sample is very, very small. But over time, we would be able to add to this, and eventually we would have several hundred people that we would have tested, and that would increase the robustness of our model. So how do we start going about making this regression equation? So like I said, the variable of interest, for example, is the VO2 max values. So that's something that I want to start with. These are your absolute values in terms of liters per minute. I'm going to start taking the relative values. So I will copy and paste these into a new sheet. Remember, right click, paste specials so you can get the values. Go back, I'm just going to copy this title and paste it in here, but change that to moles per kg per minute. And then I'll just extend this out a little bit. There we go. Okay. What values do I want to use in order to get this prediction a little bit more accurate? Oh, the other thing is, remember this 9th value I'm going to delete. That's the one for Claudius that I don't want in there. So that's this model that I have here. I'm just going to delete that in the meantime. Okay, so I'm interested in whether I can use values that I measured in the 3MT to predict what the VO2 max was during laboratory conditions. So I'm going to copy and paste all of these values in here. Good. Then I also want to try and see maybe age, height, and weight would be variables that I'd want to factor into my model. So I'd put those in, and we'll leave it there for now. I think that should be a fairly good start. Just neaten it up a little bit. Okay, so first things first, I'm going to run a regression to see which one of these values tend to correlate the most. So remember, I'm going to go to data analysis, and then I'm going to run a correlation. Okay, I'm going to make sure I include all these values over here, and then I press enter. My data is organized in columns. I do have labels, and then where do I want to output that data? Yeah, let's put it up here. Press OK, and I should see a whole bunch of correlations. Remember, a moderate correlation at the very least is something that I need, so I kind of highlight a bunch of these variables that are greater than 0.5, and I can see that there are quite a few that are already correlating. So that's a good thing. So in terms of my VO2 max, I'm pretty much interested in these values down here. So which of my independent variables correlate the strongest with my dependent variable? So since VO2 max is the one that I'm trying to predict, these are the ones that correlate the highest. So there is some I guess good news involved in this, the fact that these tend to correlate quite well. I'd also want to try and check which of these values that I want to start including in my model correlate quite highly with each other. So you can see here that, for example, my 3MT critical velocity is quite highly correlated to my 3MT maximum distance. So you'll find that eventually, I mean, this is getting really specific now, but these might interfere with each other in the model. But we'll see how that goes. Okay, so now that I've got this regression, the next thing that I would want to do is to start seeing if I can build a regression model around that. Again, I'd go to data analysis, and then I'd go to my regression. Remember, the Y value is the one that I want to predict, which is my VO2 max. So I'll highlight that. My X input range is the variables that I want to use in order to make that prediction. Yes, I want labels in that. My output range, I'll put not down there, I'll put it up here. And I don't want that. And I'll put these in. You guys don't have to tick these. This is just for something else. And then click OK. And then I have my summary output. So let's just try and interpret some of this data. So multiple R, I think in your guys' stats class, you guys learned that as your R value, it's your coefficient of correlation. And you can see here that's very high, 0.99%. So it means basically the strength of this correlation is very, very high. So that's good to see. My R square value is my coefficient of determination, basically saying that how much of my prediction can be estimated. So how much in terms of the values that I'm trying to predict are influenced by these variables here that are in my model, and that means 99.7% of these values will influence this value, which is also really good to see. I'll actually use the adjusted R square value because there's more than one predictor. So you'll see that that's slightly lower, but it's still very, very high. So that's good to see. I'm glad to see that. In terms of the ANOVA, so how significant is this regression model? How statistically significant is this regression model? And you can see here that my level of significance is less than 0.05. So that's also a very good thing. So it's highly significant. It's even less than 1%. So that's good to see as well. So it's not just due to some random error, some random chance. The probability of seeing this due to randomness is very, very low. So that's good to see. And then this is the part that I'm really interested in. Which of these variables have the lowest p-values, so meaning that they are statistically significant. So anything less than 0.05 is something that I want to take note of. So in order to do that, often I'll just run a conditional format. I'll add a rule where I say highlight any cells that contain values that are less than 0.05, and I want you to highlight them in yellow for me, and then I'll press OK. So these are the ones that are statistically significant to my model. And you can see here there's one that is not. So often what I would do is I would eliminate this because it's basically going to be a useless variable in my model that I would use for my predictions. So what I would do is eliminate that. So in essence what I'll do up here is I'll highlight this column and I'll delete height, and then would rerun this regression. So what I'll do now is go to data analysis, regression, click OK. That's still going to be the same. I'm still using VO2 max as my prediction, the thing that I want to predict. But my X output range, I'm just going to re-highlight these values, press enter, and I want it to be put in the same place as before. Actually, let me just put it next to it. I just want to double check. Nope. Yeah, I'll put it here. And then press OK. Yes, I want to overwrite those values. So that's fine. Like I said, these graphs over here, you can basically get rid of quite a few. I would use this for different analysis. Or to check the accuracy of my model, but that's, like I said, a little bit beyond what you guys need to do at this point. So let's just delete them. So you can see here that my regression significance, but not significance, the statistics in terms of what the coefficient of correlation is. It's very, very highly correlated. That's good. We've already talked about that. The significance of my regression model is also great, so it's highly significant. Again, I would just run these p-values again, just to make sure that that they are still significant. I highlight the values. Anything less than 0.05, make it yellow, click OK, and OK. Good. So that should be all my values now. So that's really good to see. So now I basically have an outline for my model. These are the values that I would want to use in my model. I'll show you what that basically looks like. So you guys will basically be creating a formula that's in this format. So it's saying that my y variable, the one that I want to predict, is equal to this whole messy looking thing. But basically I have a whole bunch of coefficients in front of my x values. And there can be a whole bunch. It can be 2, it can be 5, it can be 1, it can be 10, I don't know. It really depends on your model. And then I have an intercept at the end. And these x values are the variables of interest, the ones that I use to make my prediction. So you can see here that critical velocity, d prime, maximum distance, age, and weight all feature my model. These are the coefficients, in other words, those kind of beta values in this alpha, that I will need to use in my equation. What is of interest is not necessarily the sign here, but if you look at these correlation values, the sign here is obviously of interest. So in essence it says that if this is positive or negative, gives me the direction in which VO2 max changes depending on a change in this. So for example, VO2 max is positively correlated with critical velocity, so the higher my critical velocity, the higher my VO2 max. Makes sense. The faster I run, the more oxygen uptake I would require, right? This is the size of this is also, and I'll get to that just now. Same thing with 3mt maximum distance. So the further I run, the higher my VO2 max is on average. Age, the younger I am, the higher my VO2 max is, and weight, the lighter I am, the higher my VO2 max is. So that's good to see there. These coefficients are of interest. Basically, it's saying that for every 1 meter per second increase that my critical velocity is, my VO2 max value will go down by 27 moles per kg per minute. For every 1 meter that I cover extra, my VO2 max is going to go down by 0.1 moles per kg per minute. For every in terms of d prime, which means the higher my anaerobic capacity, the lower my aerobic capacity in essence, right? Makes sense. Distance, positively correlated. For every 1 meter that I run further, my VO2 max goes up by 0.17 moles per kg per minute. For every year that I'm older, this goes down, and for every kilogram that I'm heavier, this goes down. So these values tend to link basically the direction of the correlations. Not quite though. Alright. So next part is, how do I start creating my formula? So I've already done it here. In essence, it's just restating this formula over here. So my Y is the VO2 max in moles per kg per minute that I'm interested in. These coefficients in front over here, I get directly from here. Don't try and round it off. Copy and paste each of these values into your formula. You can see I've rounded it off here, but that's just to kind of keep it in the screen. Over here, let me fetch the formula for a second. I'm just going to go back over here. I've already done this. So this is what the formula looks like. You can see there it's a lot longer, right? I'm just going to paste it in here. So this is the main reason I didn't put it in this particular format, because it is very long. But in essence, that's what your full formula looks like. Now, the thing that you want to see is how accurate is your model in making predictions. So what you can see here, I've entered the values for one of our participants, and I've put in his critical velocity, d prime, distance, age, and weight, and I then use that to calculate what his predicted VO2 max in moles per kg per minute is. And you can see here it's 48.39 moles per kg per minute, and I use that to compare it to his actual value, and notice how almost exactly the same they tend to be. And that's, again, a strength of this correlation, right? Or this regression. The fact that it is so high in terms of the coefficient of correlation and the coefficient of determination. Remember, we said that how much of these values will be able to predict what this value will be here. So 99% of it. That's really good. And then it depends on the size of your p-values, how significant these are. You might find that when you do the analysis in your own relative to what it is that you're trying to find out, you might have to play around with a number of variables in your regression model, right? I just plucked a whole bunch of them, see what works, took out whichever ones were not significantly related. But it can vary, depends on how you tend to group these and so on and so forth, right? So you might find that there's no significant p-values, in which case you can't build a model around that. So say, for example, you want to see if you could predict what your critical velocity value is in the 25 meter versus your critical velocity, or whichever values tend to predict what your critical velocity is in the values that you've measured. So is there a way to I guess transfer or predict one value based on another value in another test? That's just kind of giving you guys a hint in terms of the direction that you might want to look at going. But like I said, the main thing that we want to try and predict is your VO2 max value. So the goal is, if I just plug in these values, in other words, if you did a normal 3MT test and I managed to determine what your critical velocity is, I managed to determine what your d prime is, the distance that you ran, and I have your age and weight, I can predict what your VO2 max is fairly accurately, right? It depends on a whole bunch of other things, but that's beyond the scope of this particular video. Anyways, I'm talking too long. I hope that's made sense. I hope you guys know how to do the regression side of things. Key takeaway factors: run the correlation, see which values tend to correlate at least moderately, so it should be at least a 0.5. Then run your regression analysis. Have a look at these values over here. Look at the significance of the regression model, so hopefully that's statistically significant, so less than 0.05. And then in terms of the variables within your model, include only those that are statistically significant or less than 0.05. Yeah, then build your model from there. Hopefully that's made sense, and I'll see you guys in the next video.